Let's take a look at an illuminated LED button. Not just any LED button, but an Otis elevator LED button. So let me show you what this looks like in the dark. Here we go, a nice shiny metal button with a red halo around the outside. It looks quite nice. It's a very attractive button. Okay, watch your eyes. The light is coming back. So let's take a closer look. I'll zoom down a little bit so you can see it in more detail. On the back of the button is a little 4-pin connector. I thought it was 2 for the LEDs and 2 for a button, but it turns out that one of the connections is not used, as I'll show you in a moment. There's a common positive 24 volt, there's a switch negative for the LEDs, and there's a switch return for the switch itself. Now, if I move it along to this pin, it means that when I press it, it will light, but only while pressed, because it's now going through the switch. I don't know if there's any advantage to doing that, but it can be done. So if we take a closer look at this, I'll pull the connectors off it. No, I won't. Yes, I'll put them back on afterwards. I initially couldn't work out how this came out. It looked as though it was glued in, but it turns out it's bayonet capped in. And it's kind of deceptive because the black in the circuit board has a bit missing just where it goes under the little latch. And initially I couldn't get it out because there is a little ramp that goes up. So what I did was I got a pair of tweezers and I stuck the tweezers in here and here and then twisted, and that released it. When you release it, it has the little red, very cheap tactile button on it, and it's got the 5 LEDs around the outside. I've already taken a picture of these so I can show you them, but before I do that, let's power it up again. So here is the positive, and we'll stuff it on there, and the negative, we'll stuff it on there. 5 little LEDs to give a nice even illumination around the outside the button. Very nice. Okay, let's take a look at the pictures, and then, well, I have drawn the schematic out, but you're not going to be too impressed with the schematic. Before I do that, let's take a look at this. It's got a black locking ring, a translucent plastic front with a metal insert going down through it, and then a sort of like white base to it. I haven't tried getting this out because it looks as though it may be crimped in. I'm not really sure. It doesn't look like it's going to come out too easily. Okay, let's take a look at the pictures. I shall zoom out a bit and I shall focus down onto where we're at, which is right there. So here's the connection in the back, and here are the connections. The common positive, the LED and resistor array inside going to the LED negative, and then the switch going to this one. Now I'm guessing there must be other options. It maybe just have the switch, a volt-free switch between these two contacts, but it just keeps it simpler if you get 3 wires. And it means that if you want a logic input like 5 volts, you're going to have to potentially use a potential divider on the switch input just to get it down to the correct voltage for your circuitry, or in some instances just use a current limiting resistor. It depends what you're doing. Some of them use an opto-isolator input just for that extra layer of protection against the electrostatic discharge of people pressing the buttons. This one is actually marked FAA AD311L34. That does appear to be, as far as I can see, an Otis code, but it may be an obsolete switch, not sure. Some of the listings for this said obsolete. These switches are £100 each. Others said £20 each, and well, AliExpress has them for you much cheaper than that. Although the AliExpress ones, they don't do the bayonet capping thing. They just have a couple of screws through. Now see this little bit here. See the little bit where the black solder resist is missing? That's what caught me out, because it's under the bayonet capping bit. That slides under the little catch. Let's take a look at the other side. I shall swivel it up that way because it just suits me better to do so. And I'll zoom down a bit actually. So the common positive comes through underneath the switch, as does the return from the switch, through plated through holes. And the positive also goes out and feeds. It's quite a convoluted route it takes. It goes out under this resistor, 620 ohm, through this LED, through a 620 ohm resistor, this LED, 620 ohm resistor, this LED, then this mysterious position here, which isn't used, and then through that LED, and then it goes down here, up here, and to the negative via that 620 ohm resistor there. It's quite a strange route it takes. The only reason I can think of this, which bridges out one of the LEDs, is maybe in an alternative design, because it makes sense that once they've designed the complex exterior that fits into the bayonet cap mechanism, it makes sense just to use that as a template and then just shuffle components to suit an application. And I get the feeling that maybe in a different application, these two might have been LEDs to light a central logo through a light guide, but it kind of, the way it comes in under this, it comes in under the metal plate, but it could have been an illuminated button in the middle with a different coloured bezel, in which case it would make sense to actually go down onto that and have a light guide up into the logo itself. So that's the only reason I can think of this odd position here, because that would then have been a resistor, this would have been a resistor, but completely different track layout. The switch itself is just a generic tactile switch, you know, the type that would cost 10p. The ones that will go intermittent after a while and then just stop working, because that's what these switches do. And if you have one of these elevators or whatever and the switches start giving up on it and going intermittent, well, now you know that it's a standard tactile switch surface mount. There is a sizing system for those at 9.5mm or something, or 6mm. 6mm tactile switch, but the height of it, let me see if I can get this. Oh, I can't do it with this set of calipers because they don't have that depth mode. Let me just cause an avalanche here. Let me just check this. The total depth of the switch is about 5mm. Interesting. Nice that it uses standard components. Okay, let's go to the schematic, and as I say, you're not going to be too impressed. There's really not a lot to see here. So we've got the common 24 volts, and it goes to the switch common, and the LED common goes through the switch to the switch connection, goes through two LEDs, resistor, LED, resistor, two LEDs, resistor, and back to LED negative. It's worth mentioning that at 24 volts, it was 10 milliamps going through the LEDs, so they're not being pushed too hard. That's good. It's also worth mentioning that the availability of these buttons, they're available in other colours like blue and green and white, but keep in mind that red, the classic red LEDs, the gallium arsenide LEDs versus the modern gallium nitride ones, they are super reliable. The LEDs will probably never give in these buttons unless water gets into them and causes corrosion. But there we have it. You know, it's a nice little button. It's quite smart. It's got the proper elevator feel to it and look. And they're available from AliExpress for about £5 each. So, you know, if you've got an application you want a fairly rugged button, then that might be worth considering. But there we have it. It's always interesting to look at elevator components, particularly Otis, because they've got such a pleasing pedigree behind them, because they're the iconic lift company that invented the safety systems that made lifts available in the first place. But there we have it, an illuminated Otis button. You can get them on AliExpress if you fancy buying some and having a play with them.